Hey guys, sorry for not being there today, but I do have your lesson done for you. So let's go ahead and take a look at our area of a regular polygon. So this isn't like the normal area that you guys been taught. This is a little bit different, but nothing about it is too terribly difficult. So first, let's go ahead and start with the parts of a regular polygon. And so the distance from the center of a polygon to any side is actually called the apothem. So this will be the apothem. And the radius of a regular polygon is a distance from the center to a vertex. So we are looking at our picture here, and you should be labeling this on your own paper. From the center to any one of those sides, that is our apothem, so that's our A. And then our radius is from the center to one of these vertex, so that's our radius right there. And when we're actually given both of these things, we actually have a very simple equation that is A is equal to 1/2 A times P, so A, your apothem multiplied by your perimeter. So here, there, and our perimeter is all sides added up, so in case you forgot, that is all sides added up. Okay. So let's go ahead and check out a problem. So remember, our equation does require two things. That is 1/2 times our apothem times our perimeter. So some of these things are pretty easy to find. Our apothem, remember, from the center to the edge, that will be 7. But a perimeter is one of the mistakes that you guys make the most. A perimeter is all our sides added up. So you guys tend to see this 24 right there, and you automatically believe that is our perimeter. That is just one of our sides. We still have 3 others. So this side is also 24.2. This side is also 24.2. So what you can do is add all those sides up, or you can just take that, multiply by 3. Just the number of sides that we have, and then we actually find our perimeter. So we would say 24.2 times the number of sides, and we actually end up getting 72.6 for that. So I'm going to come down here, replace my P with 72.6. This entire thing can be put into the calculator at once. Let me show you. So we take our calculator, we say parentheses 1 divided by 2, multiplied by our apothem, which was 5, multiplied by our perimeter. Just kidding, it was 7, right? Yeah. So this was 7, and then multiplied by our perimeter, which was 72.6. So that ends up being 254.1, and that's our answer. So here, our A does end up being 254.1. That's it. So I want you guys to look at number 2, and I will set it up for you. Well, I'll write the equation for you guys. So 1/2 times our apothem times our perimeter. Super important, that is our perimeter. So you got to find that one first. Okay, so go ahead, find our area, and go ahead, get your name tallied off, and then continue the rest of this video. So that was pretty easy, I believe, but it does get a little bit more complicated when we don't have the apothem or the side length. And so there's actually quite a couple steps, and it does get quite lengthy in order to solve these, but I do want you guys to kind of bear with me. Nothing about it is too terribly difficult, and hopefully you guys won't have a problem with it. So our first step is to create a right triangle by drawing the apothem and the radius. So they've actually already given us our apothem here, so the only thing left to do is to draw the radius. First step is done. Second step is to find the measure of the interior angle. Once we do that, we have to divide it by n. and then divide by 2. So remember, this is something we've done before, the sum of interior angles. We actually do have a typo here. Let's go ahead and change that to multiplied by 180. And then if you forgot here, the n does equal the number of sides. So in case you forgot, that's what that n stands for. So let's go ahead and do that. We would say s is equal to the number of sides minus 2. So that'd be 1, 2, 3, 4, 5, 6. So that would be 6 minus 2. And then we would multiply that by 180. And so when we do that, again, that can't be input into the calculator all at once. We should get 720. However, 720 is that sum of those interior angles. We still have to find each one of those individually. That's where this comes in. That's when you divide by n, aka divide by the number of sides. So we said that was 6. So we'll take 720, divide that by 6. And so that should be, let's see, divide by 6, 120. That should be 120. However, we are not done yet. We still then have to divide by 2. So let's divide that by 2 and we should get 60 degrees. That is what we're looking for right here. So what we have found is that each one of these is 120. However, we do have to divide that by 2 because we're not using the entire angle. We are just using this corner angle right here. And it's always going to be the one with the vertex. It's never going to be that central angle. So it's going to be across that 90 and into that vertex. So this right here, that is what our 60-degree angle looks like. So after all of that, we have finally finished step number 2. Nothing too difficult yet. Number 3 says, use special right triangles or trig to find the apothem or the side length. So in this case, we do have our apothem, but we do not know this side length right here. That is my x. That is what I'm looking for. So actually, we are going to be using SOHCAHTOA still. So we are not forgetting about that. We are still using it. We could use special right triangles as well, but let's use SOHCAHTOA right now. First thing I'm going to do is label my triangle. Remember, we start out by labeling the hypotenuse, and that's always going to be across this 90-degree angle. So that is going to be my H right here. We are working with our 60-degree angle here, so the side opposite of it, that's going to be my O. And the side that is next to it, the side that is touching it, that's going to be my A. So here I have to take into consideration what I have been given. I have been given a value for my O, for my opposite leg, that is 5. And I have also been given a value for my A, that is X. I don't know that value yet, but it is still considered a value. So if we look at our trig over here, there's only one of these that needs an O and an A, that is tangent. So tangent is actually what I'm going to use. So I will be saying tangent of 60 degrees is equal to my opposite divided by my adjacent. So my opposite here is going to be 5 divided by my adjacent, which will be X. And so we can now start our trusty butterfly. So I'm going to put this over 1, and then I'm going to draw my butterfly. Oops, right there. So we would say 5 times 1, that is just 5, equal to tangent of 60 times x. That just becomes tangent of 60, of course, times x. We are trying to solve for that 5, so let's, not for the 5, for the x, so let's divide 5 by the tangent of 60. This gets canceled. And so now we have x is equal to 5 divided by the tangent of 60 degrees. So one thing before we go ahead and solve for that is you do have to change the degree mode on your calculator. So go to mode, go down to radian, over to the right, make sure degree is highlighted and blinking. Okay, so change your degree mode. Again, go to mode, go down to over 1, click enter, degree should be highlighted and blinking. So let's put that into our calculator. We would say 5 divided by parentheses tangent of 60, close it twice, press enter. You should get 2.8. So x here is equal to 2.8. However, we have only found x. We need that entire side length. So what we do is actually multiply that by 2. And when we do that, 2.8 times 2, we get 5.78. So now we know this entire length right here is 5.78. That does come in handy to us when we find our perimeter. So our perimeter is all these sides added up, or it is all those sides multiplied by the number of sides. So in this case, that would be 5.78 multiplied by 6, because we have 6 sides. And our perimeter actually ends up being 34.68. 34.68. And so finally, after all of this is done, we can go ahead and find our area. So we would say the area is 1/2 times our apothem, which is 5, multiplied by our perimeter, which ends up being 34.68. And when we do that, you should get an area of 86.7 centimeters. For number 4, I do want you guys to try that out on your own. I will be doing 2 things for you. I will be drawing your radius. You should be drawing us the same way. Remember, when we find our angle, we are using this angle. As well, for number 5, I do want you to do that one on your own. I will be drawing the radius for you. Here we go. And so then we are looking for this angle when we use our trig. So find number 4, move on to number 5, go get those 2 checked, and we should be done for the day. So go ahead, do those 2, and then bring this sheet tomorrow, because we will be finishing it up tomorrow.